Hello, I'm Teacher Cole. All right, let's take a look at this question, which is about water, right? Water cycle. Sophia bought a handheld mist fan as shown in the diagram below. When she presses the handle down, water in the container is transported through the tube and up to the nozzle, which sprays out tiny water droplets into the surrounding air. Explain how this handheld mist fan is able to lower the surrounding temperature when tiny water droplets are sprayed into the surrounding air. Now, this kind of fan is found like every time we go to the theme parks, they do sell this kind of mist fan, right? It is by just basically spraying water around you and you feel so cooling. But how does it work? How does it work? You just spray water. How does water cools down the surrounding air? So the secret comes with evaporation, right? So how does evaporation cool things down? Because we know that when water evaporates, you have to gain heat to evaporate. So when water gains heat from the surrounding air in order to evaporate into water vapor, the surrounding air actually loses heat to the water. So we call this the cooling effect of evaporation. All right. So how do we put this in words? So the water droplets, right, gain heat from the surrounding air to evaporate into water vapor. So when they gain heat from surrounding air, the surrounding air will lose heat to the water droplets and become cooler. Now, I put a second sentence in brackets because I think it's optional, all right? Because water droplets gaining heat from the surrounding air is the same as surrounding air losing heat to the water droplets. But the second sentence is useful because it addresses the surrounding air. It answers why the surrounding air will cool down, because the surrounding air loses heat, although it has the same meaning as the water droplets gain heat. Okay, so that is the part A. Now let's take a look at part B. Explain how turning blades can help to cool the surrounding air faster. Now, to do this, we look at the factors affecting the rate of evaporation. Now, if the water can evaporate faster, won't it gain heat faster and turn into water vapor faster? And therefore, surrounding air will lose heat faster, right? So the three factors of affecting the rate of evaporation is wind, exposed surface area, and temperature. So when you're turning the fan actually creates wind, and this wind can increase the rate of evaporation. So therefore, the water will gain heat faster and evaporate faster. So that's one reason. Let's put it down. Right, so the wind gain from a fan increases the rate of evaporation. So the water gain heat from surrounding air faster and evaporate the water faster. So because it gain heat faster, the surrounding air will cool down faster. That's actually a second reason why it will cool down the surrounding air faster. It's because the wind will spread out the water droplets. So when the water droplets is being spread over a bigger area, right, spread out, it actually gains it faster. It's more effective. It can cool down a bigger area at the same time rather than a small area. All right. So because it can spread out over a bigger area, it will also surrounding air will gain it faster and also lose it faster to the water droplets. All right, so the wind from the fan can spread the water droplets over a bigger area, so the water can gain heat from the surrounding air faster and evaporate into water vapor faster. Okay, so there are two possible answers here. You can write both if you want. Yeah, why not? Let's take a look at part C. Without changing the parts of the fan suggests two ways that can help Sophia cool the surrounding air faster. So we want to cool the surrounding air faster. Again, we can look at the rate of factors affecting the rate of evaporation. But what we can do is we can increase the amount of wind. So you can press the handle faster. By pressing the handle faster, you can actually spray more water, and therefore the water can evaporate faster. Right. Another way we can do is to add some ice in the water, so the water become cooler. All right. So you will also cool the surrounding air faster. I think these are two ways I can think of. What do you think? Can you think of other solutions? You can let me know. All right. Okay, so that's all for this question. I see you again in the next video. Goodbye.